Oh.
Hello everyone, it's November 13th. Alright, a bit early today. Was good, but I didn't go to gym. I was supposed to go to gym, but then work took a little bit too long and I decided not to go. I don't want to go. I got a bit lazy, I agree. But it's the transitional week, so it's fine. Doesn't matter that much. I can actually do 2 sessions tomorrow if I want to. All right, increment submatrices by 1. I've done this before. I probably put it as a nightmare, which means it's tough. Oh, I put it as a good interview question. Okay. Positive integer n, indicating that we initially have n by n. It also came out to the query. Row 1, column 1, row 2, column 2. You should do the following operation. Add 1 to every element in the submatrix with the top left and the bottom right. That is, add 1 to this. Okay. Return the matrix after performing every query. We have n is 500 queries, and we have this and this. Oh boy. I don't remember how I solved this. I feel like segment tree, right? It feels like segment tree. But technically, we can do segment tree on every single row. N is 500, so we can have 500 segment tree. But if we have this range is big, I don't think that's possible. All right. How you do it in the 1D? Okay, let's just say we have a 1D, and then we say from here to here, right? And then we say from here to here, and then we say from here to here. How would you do it? Well, we'll do line sweep, right? So we'll do +1, and then -1, +1, -1, +1, and then -1. And then we'll do a prefix sum, and then we can figure out what it will be. So if that's the case, can we do the same with 2D? So for 2D, can we do rows and columns, like 2 of them? So here's what I'm saying. So I have, let's say, rows. So we create a rows. So we don't do columns here. And then we do a columns. Oh. So we see a 1, 1, 2, 2, right? So 1, 1, 2, 2. So basically we do a row. So we just +1. And columns are handled by the columns. So 2, 2, right? 1, 2. So 2, 2. So 1, 1, 2, 2. So it's just going to be 1. And then 1, 2. So this will be 1 for the row. Then how about columns? Why are you going to overcount? I am going to overcount. So I can do this row. Hold on. And then, oh, bring it down. Ooh, that is an interesting idea. But it's not necessarily a square, right? You know what? I think I'll just do rows. We'll just do rows. And most, so it's gonna be OM times N. I think should be fine. All right, what do you think? Because each query will just do like a +1 - 1, +1 - 1, +1 - 1. That's what we do. So every single one, yeah, it'll be 500 at most. And then, because if we don't do that, right, if we do just top left, and then we have to go diagonal down, right, we have to go diagonal down, which I don't really think works. Yeah, okay, we'll just do a line sweep on every single one and hope that it's sufficient. Let's try line sweep. All right, on every query. Queries, but I need the answer, so I'll do the answer first. Okay, then what? Then we do queries for okay. So we have 0, 1 is this and this. So what do we do? All we do is go through every I. So we say for Q0 2, right? Because this is a row and this is a row. And then what we're gonna do is res. So so I Q1, right? So this is the top left. We start with this. Well, plus equal 1. So this will be plus plus. And then on the right hand side, say if Q0, 1, 2, 3, right? 3, if that is smaller than n, actually if it's smaller than n minus 1, right? Because I need to do this one plus 1. Then we say res I q3 plus 1 minus minus. Okay, and then once we've done this, this is line sweep. And then after that, we'll do prefix sum. We can say for int j, we say res I j equal to plus equal to res I j minus 1. Okay, let's give this a run. Actually, this should be plus n squared. Okay, here we go. Okay, that was the accepted answer. I'm really hungry. I need to eat. So the previous time I did 2023. It's a NumPy solution. Oh, I forgot how NumPy does this. Holy crap. Yeah, you can do NumPy. Gourd. Oh, it's the same. It's the same idea. It's the same idea. It's the same line sweep idea. So this one, this plus 1, minus 1, minus 1, plus 1. I see what they're doing. So this is plus 1, right? And row 1, column 2, this is minus 1. This is what we do. And then row 2 plus 1, column 1, that's the left bottom. Minus 1, yes. And then this is the right diagonal. Will be plus 1. Why is that one +1? So we'll do left to right, and then we'll do top to bottom. Top to bottom on the +1, -1, and then I have, this is -1. This is the first row. Column 2, yeah, these two I understand. This is row 2, column 1. Row 2, column, row 2 +1, column 1. This is the first column, I understand. This is row 2 and column 2 +1. This is diagonal. So basically, it's I'm trying to understand what this one is. So basically, this is +1, -1, I understand, and then -1, I understand, and you have this here is +1. That I don't understand. So you definitely do left to right. Hold on, let's see. X1 is -1. So X1 is here. So this is X1. X2, this is X2. X3, this is X3. So this is going to be the diff plus X1, yes, plus X2, yes, because that, and minus X3, minus X3. I think I know why. Because you do the line sweep here, and you will do the line sweep here. So this one gets double counted. So how do you avoid double counting? You put a +1 here, which means we'll have a +1 here. So we'll minus this +1 here. So if it's a +1, then you do, I don't know, it feels, I don't know. I don't think it's as intuitive as this one. This is just line sweep every single one. It feels more intuitive. But it does probably take a little bit longer because we have to go through this, right? But boy, this is hard for me to understand. It's the diff, right? It's the diff. It's a prefix sum over two-dimensional array. Yeah, because for each cell, it's influenced by the one above you, right? And it's influenced by the one to the left. So you basically handle both. But why do you do the minus? I think it's like if this is like if this is our cell, our thing, and then you're trying to compute this one, right? So you get influence from here and you get influence from here. Therefore, you need to remove the influence from here. So yeah, okay, that I can understand, that I can handle, but it's not right here. It's like if we do the influence here, right? It's still this, and this, because this value is already computed, right? This value is already computed. So this is the true value at this position, right? This is the true value at this position. And when you compute this one, because this is all included, or like this, or just by itself. Not very sure. I understand that this one is accumulation of this and of this. This I understand. And I also understand that it will overcount. I understand. But why minus this can help? That I do not understand. Minus diagonal. Because technically the row and column should be right. Well, but keep in mind, if I have something here, then this one actually will have a +1. I don't know. Feels like magic. Yeah, I know it works because the solution works, but it just feels like magic to me. Especially this, like, huh? How'd you come up with this +1? I mean, it feels like it's just +1 is, I don't know. I have no idea. It just it just +1. It's like a diagonal, right? Like a row, column, and diagonal. But instead of diagonal, we +1 on this diagonal, and then we just, I don't know. Yeah, I'm doing inline sweep. So this is basically a 2D sweep, but if you ask me to explain, I really can't. Like, I understand the row and column, but the diagonal part is just, like, how do you do the diagonal part? It's a sweep as well, right? It's a sweep, which means you do prefix sum to fill in all this blank. And remember, we only do this and this, okay? So if we do row column like that, how do we know this one needs to be even updated? I don't know. Okay, I don't know. All I know is I got rows and columns, and I have diagonal. So we do this, this, and this. And then we'll plus, which is fine. And each one will. Oh, So hold on, each one will plus, like you go through row by row, but each row will also plus from the sum from top, right? So okay, so we'll plus the sum from top. And the sum from the top gets influenced from this. Yes, you get influenced. So which means you get one share from here, and you'll get one share from left to right. Right, you got one share. And then you got one share from top down. And both shares are contributing. Yeah, so this I got one share from here. I got one share from here. But this share comes from here. This share comes from here as well. So I got two shares. Right? I got two shares. But I need to remove one of them, so I remove this one. That actually makes sense. Okay, that makes sense. Then why this plus one? Yeah, so this negative. Oh, I think I know, because this negative gets carried all the way here. This negative gets carried all the way here. So the negative gets carried twice. That's why I plus one to negate one of the negatives. Now that makes more sense. Very smart. Okay, that'll be it. I will see what the hell did I do.